Good day, folks. This is Greg Judy at Green Pastures Farm. Today I'm giving a little demonstration talk where we're at in Cochise County, Arizona. And this is a grazing project that we've been working on for about a week. And anyway, just for the background of where it starts and everything, I wanted to hand this over to Karen first to talk a little bit about the history of this plat and the land that we're working with. And then we'll hand it over to Ricardo a little bit more to get in some depth. Okay,
Hi.
Karen?
I'm Karen Riggs. I am a retired county engineer for Cochise County. I worked for them for 20 years. Started in floodplain and drainage and flooding. Worked my way up to county engineer. This is a project. This is 3/4 of a section. There were 3 alfalfa pivots on it. The county acquired the property as part of kind of a multifaceted project type thing that's going on down here to protect Fort Huachuca, a really important military installation in our county. We put a conservation easement on the property so the 480 acres would not develop. And it became clear that it would be a really good laboratory for researching and documenting regenerative agriculture and using animals and animal impact and managed grazing to improve the soil health and help us with the flooding problems, which we have a lot of in this county.
Yeah, that's great. So, Ricardo, I mean, you and I kind of came in on this project. You brought me in on it.
Mm-hmm.
And I'd like you to kind of talk a little bit more about the some of the studies you're looking at possibly doing on this, as far as holding, how much water can we hold if we break the soil capping here with livestock like we're planning on doing.
Mm-hmm.
And then I'll kind of get in at the end how we're going to, the design that we put in and stuff like that.
Okay, if you don't mind, I'll give a little background
Yeah,
on myself too.
absolutely.
So, I'm a civil engineer, studied both at Arizona and University of Illinois, focused in hydro systems, kind of worked my way up. And really for me, an inflection point in my life is when my son was born. And at that point in time, I had projected a conversation in the future with him about 15 years. And the conversation basically went him asking if I knew the environment was degrading, and as a civil engineer, if I was in a position to do something about it. And of course, I didn't want the answer to be yes, I knew, and no, I didn't do anything about it. And so I took a very hard course correction in my career to start looking and asking some heavy questions about what I was taught in both undergrad and graduate school. And the answers that I was coming up with I didn't like, because really what it was is about centralizing the resource of stormwater and treating it like a nuisance. And when I started to study nature, in particular regenerative agriculture, I began to realize that nature fundamentally decentralized the resource of stormwater. And so one thing led to another, and I found regenerative agricultural practices like permaculture and then suddenly holistic management, which really influenced me. And I started to write papers on that, which led me to a meeting of Karen about 5 years ago. And I was able to approach her at the time as the county engineer and suggest this vision as an alternative to engineering practices that weren't successful. And the vision, of course, is this project where instead of concrete and steel and holes in the ground and pipes and channels, we're looking to restore this land in order to sorb up and infiltrate that stormwater on average that rains here about 14 inches a year. I have been trained by the Saver Institute. I'm an accredited professional land management. I actually trained Karen and her staff at the time of the first phase of this project. Then I started my own firm, and I kind of felt that that firm was going in the direction that I didn't want it to. And I wanted to keep the energy and the vibration of this direction of holistic management and regenerative agriculture. So I decided about a couple years ago to get on YouTube and find somebody to just so I can listen to. And I came across Greg, and the first video that I saw was a 3.5-hour workshop that he gave, which was basically, it spoke to me, and I told Karen that it was a blueprint for exactly what we're doing. being an accredited professional from the Sabre Institute is great application, but as an engineer, I really needed to get down into the details. And that's where Greg came in, is you need to use this plier, you need to use these kinds of high tensile wire. This is how you do strip grazing, and that's what we've laid out here. And so that's really the beauty of the project. Just to wrap up really quickly, we ran some models here. The watershed comes off the Huachuca Mountains through the Piedmont, which is this site is a part of, and then we're about a mile to the west of the San Pedro River, one of the last 4 remaining watercourses that is still perennial, and Arizona is looking to maintain it and preserve it. And this site is a part of also what the Cochise County is calling, or at least part of the Cochise Conservation Recharge Network, as one of a litany of other sites, but this is the only in its kind where we're looking to look towards long-term water security for the area, like the other sites along the San Pedro. So with that, the models that we have ran started with an existing conditions where there are 3 watercourses running through the site. The largest watercourse is to the north, and at the downstream end of the watercourse, our existing conditions model demonstrates how compacted this area is. It's so great that it's basically, when stormwater flows off the site, it's essentially like it's running off concrete or asphalt. The 100-year 6-hour event is approximately 1,400 cubic feet per second.
Running off.
Running off. And we made some adjustments to the model when we looked at some of the work that Greg has been doing, as well as Gabe Brown, and how once restoring the soil biology, how that water can infiltrate and offer flood control relief as well as water quality. So we ran a predicted conditions, or a target conditions model, where we increased the soil organic matter from about 1% to about 5%, 1% of the existing. 5% was our target. And we also increased the limiting infiltration depth because we predict, as Greg as well as Gabe Brown has achieved in Soil Carbon Cowboys, that the perennial roots will increase the depth of the infiltration capacity. So increase the infiltration capacity from 8 inches to about 10 to reflect the perennial root depths. And the predicted conditions model went down to about 100 CFS during the 100-year design event. So that's a change of 1,400 CFS. 1,300 CFS. So that gives you the potential of the infiltration capacity that this site will eventually have, at least what we're targeting once we begin to offer animal impact and grazing and then resting as tools as nature intended, not technical practices like I was trained in school to implement holes in the ground and pipes and channels. So with that, Greg, I'll hand it back to you if you want to kind of get into the details of why you influenced me. And when I left your farm tour last year, I told you you're going to be my new best friend.
Yeah, I remember that night. It was a good day. You know, we came into here, and actually came in February, I believe it was. January we came out, and these two wouldn't tell me what they'd designed for a grazing cell in here. They just wanted me to have a blank map, and so they handed me the map and said, "What would you do here?" And I'm like, "Well, thanks a lot." It didn't give me any input or anything. Just here it is. What would you do? And I looked at it, and I immediately was like, you know, I like to be the artist, and so the paintbrush are my poly wires, my cattle are my tools, my paint, and so I like to keep the area open as much as I can. But you've got to have infrastructure to control the animals. You've got to have water points where you can get the animal stock and density up. And I like to be able to change the size of my paddock. So I didn't want a bunch of permanent paddocks in here restricting my creativity as an artist and as a painter. And so what I did is I just built a 2-wire fence. This 480 is an L shape. It's a huge L. And so Ricardo and Karen had a surveyor team come in here, and they ran markers all the way through here, splitting this L right down the middle. Saved us probably a good day of measuring. And so we were able to follow those flags, put the trencher on that, and he started trenching. and he put in around 8,000 feet of pipe, and then we put in that much wire, a little bit more. And this is, so basically what we have is a huge L shape, and the wire you look in the background here, going down the road, that's our feeder wire. So that's going to be where the electric fencer will be hooked in, and the water. So we ran 1.5 inch pressurized water, high density polyethylene, all the way around this farm. We didn't use any hydrants. It's all quick couplers, so they're cheap, 14, 15 bucks for a coupler. They're down in the ground, nothing can chew on them. Cows can't break them off, so it's very, they're indestructible. Very secure. And Karen, one of the things, when you started talking about the history of this, what blew me away was these irrigation pivots out here. You told me they put down how many feet of water?
Out here in Arizona on an alfalfa crop, it's between 6 and 7 feet a year. And we get 5 cuttings. Wow. So over 480 acres times 7, you can see how many acre feet that is.
That's huge.
Pumped out of the ground and put on top.
Yeah.
And then big center pivots. There were 3 pivots in each quarter. And I was trying to think how long alfalfa was raised on it. At least 10 years.
Yeah. And then after
and
that,
maybe longer.
I saw the aerials last night, and it's actually about 15 to 20 years.
Okay,
yeah.
Longer than that. So long history of
continuous grazing.
Continuous grazing.
After that,
and then in the last almost 15 years, just continuous grazing.
Yeah.
The county just purchased it a few years
so
ago.
if you wanted to beat up a piece of ground, this is the ultimate. But you know what was exciting today? Grant and I sharpened a step-in O'Brien post. I wanted to show him how to do it. And so I sharpened one, and he's going to bring one, just hand it in here. Thank you, Grant. So this is the one I sharpened. They come blunt. And I was concerned that we have a really nice grazer across the road. It's going to be bringing cattle in here, Micah. And he's like, Greg, I'm going to have to drill with a concrete bit every hole to put this in. I sharpened these, and I found if you'll just find a plant, you don't have to sharpen them. They go in the ground. That's huge.
Yeah.
So you don't have to drill.
You don't have to drill.
You
I'm
still
sorry,
have to
did I say
sharpen.
sharpen?
Yeah. It's been a long week.
Yeah, it's been a long day.
We've been
long
working
day.
hard.
Yeah, they come blunt. You sharpen that post, you won't break these off. These are expensive. Take care of them. So in Arizona, I knew we had a lot of UV. Blue actually takes UV a whole lot better than white does. So I've got some of these, and anyway, so when Micah puts in his paddocks, he's not going to have to pack a drill. He just needs to look for a plant. And there's a lot of plants out here, but there's also a lot of bare ground. And anywhere there's bare ground, so you can't, you just can't get them in. But if you find a plant, well, I don't need to be moving around. Anywhere there's a crown of a plant, it'll go right in. So it tells you the strength, the infiltration of plant roots.
Yep,
right there.
Exactly.
And so remember this, folks. Animals. It's all about animals. And until we bring ruminants onto this land to get the biology going, and recycling that manure and the urine and beating up this dead stuff after getting that thatch on the ground to build your litter bank, keep the sun off the soil, keep it cool, that's when things will start to change.
One of the things your viewers might find interesting is when they first started trenching, you told me that the teeth were about cutting 8 inches wide.
Yes.
And then when they ended,
yes,
the trench was maybe like
it was
5 or 6 inches.
It was so narrow. The trench was so narrow we couldn't get a shovel down in it. The width of a shovel, it wouldn't go down in it anymore.
A trench shovel.
A trench shovel.
Which speaks to the.
So those young guys came over here on Sunday and took pieces of caterpillar chain and welded it on the
to make new teeth.
To make new teeth
because they couldn't find teeth.
They couldn't find teeth for it. So yeah, this is an exciting project. We've got the infrastructure in, we get the water charged, get some pressurized water out here, and get our electricity turned on. I'm fired up. I think this is going to be a great project. You've got the expertise to do a lot of the monitoring, and a lot of people say, well, this regenerative agriculture, it's all cool, but show me the data.
Yeah.
That's what we're going to be able to do here.
Yeah.
So folks, I'm going to go ahead and sign off on this. I think we've covered it's a good opening round. There's going to be quite a few more videos coming up showing the details of how we put all this in, and it's going to be exciting. So hit that subscribe button on the way out and that like. I'd appreciate it, and we'll see you all down the road. Thank you.